Hi, and welcome to the last section of this course, Building Recommender Systems. In this section, we will first create a training pipeline. Then we will extract the nearest neighbours and build a k-nearest neighbours classifier. Moving ahead, we will compute similarity scores and find similar users using collaborative filtering. Finally, we will be building a movie recommendation system. Now we move on to the first video of this section that deals with creating a training pipeline. In this video, we will see how to build a pipeline to select the top k features from an input data point and then classify them using an extremely random forest classifier. Machine learning systems are usually built using different modules. These modules are combined in a particular way to achieve an end goal. The scikit-learn library has functions that enable us to build these pipelines by concatenating various modules together. We just need to specify the modules along with the corresponding parameters. It will then build a pipeline using these modules that processes the data and trains the system. The pipeline can include modules that perform various functions like feature selection, pre-processing, random forests, clustering, and so on. We have first created a new Python file and imported these packages. Then we generate some labeled sample data for training and testing using this code. The scikit-learn package has a built-in function that handles it. In this line, we create 150 data points, where each data point is a 25-dimensional feature vector. The numbers in each feature vector will be generated using a random sample generator. Each data point has 6 informative features and no redundant features. The first block in the pipeline is the feature selector. This block selects the k best features. Let's set the value of k to 9, as shown here. The next block in the pipeline is an extremely random forests classifier with 60 estimators and a maximum depth of 4. Then we construct the pipeline by joining the individual blocks that we've constructed. This is the code for doing it. We can name each block so that it's easier to track. We can change the parameters of the individual blocks. In this line, we have changed the value of k to 7 and the number of estimators to 30. We will use the names we assigned in the previous line to define the scope. This line trains the pipeline using the sample data that we generated earlier. These lines predict the output for all the input values and print it. We then compute the score using the labeled training data. We want to extract the features chosen by the selector block. We specified that we wanted to choose 7 features out of 25. We used this line to print the features chosen by the pipeline selector, and this line is used to extract and print indices of selected features. Let's run the code and see the output. The output list shows the output labels predicted using the processor. The score represents the effectiveness of the processor. The last line indicates the indices of the chosen features. So, we learned how to create a data processor pipeline that can be used to train a machine learning system.